Hello and welcome to today's video. My name is Stacy. I'm a senior data analyst and I came from a non-technical background, and I just decided to create this channel, this space, and make it a place where I can share the knowledge and skills that I've gained over the years, both non-technical and technical aspects of my career. Yeah, so for today specifically, we are jumping into the technical side of things, and we're going to be doing a data analysis project. So this can be a portfolio project. It's something that you can put in your portfolio. It's something you can use to just practice your skills, whether you include it on your portfolio or not. Yeah. So yeah, that's what we are going to be doing today. Something just crossed my mind, like, should we be uploading this? Should we upload this project in GitHub at the end of this video? I think yes. I had not planned for it, but it's definitely something that we can do at the end of this video. Yeah. But yeah, anyway, so what are we doing today? We're going to, of course, load our data, clean the data, then we're going to explore the data. And the main question which we're trying to answer is what we just want to understand which client profile is more likely to have an approved loan. Yeah. Okay, so of course, the first thing you have to do is load the relevant libraries and the data. So we're going to be using a number of libraries. They include Pandas, NumPy, Seaborn, and Matplotlib. So NumPy and Pandas are just used for data manipulation. Seaborn and Matplotlib are both used for data visualization. So stay tuned, guys. Like this particular data set, I really liked it. I really enjoyed it. And I see how we can actually turn this project into a data science project, actually build a couple of machine learning models. So if that's something that you're interested in, if that's something you'd want to see me convert this project into, do let me know down in the comments below. Otherwise, so make sure you load this data set. Run this cell so that you have the libraries you need. Yeah. And then the next thing is we need to preview our data. But before we preview our data, we need to even load it into our environment. Yeah. So I'd already navigated to where the data set is. So when this dialog box appears, just navigate to navigate to where the data set is and load it. Yeah. Then for previewing the top of the data set, we need to load it first, yeah? And this is the first, now for this project, this is going to be our first interaction with Python Pandas, yeah? So we're going to name this data loans data, yeah? And now we need to read it, like we need to access it. So pd.read, yeah? So pd.read underscore CSV, here it is pandas function, yeah? Then we need to put the name of the file that we want to read. So I like doing rename. Okay, so the name is, like in this case, I actually didn't need to do that, but I've just gotten used to it because I prefer to copy paste, because sometimes you could control copy, yeah, .csv, and then you have to put this in quotes. So I was saying I prefer to copy paste just to minimize like the chance of an error occurring, yeah? So we have loans. So our table is called loans underscore data, yeah? And if you want to view the data set, specifically the top, we'll use a function called head. So see, while it's like to copy paste, minimizes the chances of an error. So there, that's our table. So we can close this. We don't really need it for now. Yeah, I'd already like created like the flow of our project. So the project plan, this is the title where you can get the data set. I'll put a link for you there. So I'm going to link this project, this Google Colab down below. So yeah, you can access it and use it for whatever. Yeah. So we're going to clean the data, explore and visualize the data. Yeah. So we look at number of applications over time, then we'll explore the annual income variable and others. Yeah. Okay. So this is the data. As you can see, we have application date, age, annual income, credit score, interest rate monthly, loan payment, total debt to income ratio, loan approval, loans that were approved, and risk score. So if we're going to turn this into a data science project, the loans approved would be our independent variable. It would be our dependent variable, because your risk score, your monthly loan payment, your base interest rate, those are independent variables that will determine your dependent variable, which is the loan approval. So this loan approval is dependent on what you score, or let me just say what you score, regardless of whether it's an integer or a categorical column, because you could be employed, not employed, your education level. So let's just say master's, associate, bachelor, like those data points are like scores. Yeah. So depending on the scores you have on these various independent variables, it will determine whether your loan will be approved or not, which is the dependent variable. Yeah. If we turn this into a machine learning, a data science project, so we build some models to just help us predict. So if that's something that you'd want to see me do let me know. Okay, so it's good to, of course, preview the top of your data set, because you just want to get a feel of, okay, what am I working with? Yeah, but it's also good to preview the bottom of your data set. So most of the time, it just gives me like a feel of, okay, how messy is this data? Because most of the data sets that I've interacted with, you'll find that the majority of the missing data, like the dirtiness and tidiness of that data set, is very visible at the bottom. So I could be wrong. That's how I use tail. I'd want to know, like, why do you preview the tail, the bottom of the data set? Yeah. So just by looking at this, I have a feeling this data set is going to be pretty clean. We're not going to be doing so much data cleaning. Yeah, I have a feeling. Yeah, so which is a bit sad, because why you jumped onto this project was because you want to see the data cleaning aspect of like like how to do data cleaning with Python. It will be very limited, but yeah, I have other Python projects. I'll just link them at the end, and some of my Python tutorials. And yeah, I think one of them, I did a bunch of data cleaning, so it will be better practice for you. Yeah, I've forgotten what it's called, but I'll link it first. It will be the one on your left. Okay. So, what next? We get into, now that we have an idea of our data, my hypothesis is, like, I have a feeling that this data set is pretty clean. Yeah. So the next thing we're going to do is to just look at the data type of our data. So our data set is called loans underscore data. So you're going to use info. Yeah. And this is going to give us our data type. So as you can see, majority of our columns are integers, yeah? So I would counter check the objects, yeah? So like we have this object, application date. So that's already something that we need to clean, because this is a date. So we need to change this to date type. But most of the other things, so of course, age is an integer, annual income, credit score, employment status is an object, education level is an object. So object is just a character, like it's in words, for lack of better words. So again, if some of these things you're not too familiar with them, I have Python tutorials like Introduction to Python for people who are new to data analysis or data science. You can check that out. I'm going to link it at the end of this video. So in case, I'm going to pass through these things very quickly. Not very quickly, but realistic pace. Yeah, so if you want an in-depth explanation, you can check out the tutorials I already have up. So what are the first data cleaning step we took was first step we took in the data cleaning process was to check our data type. So for sure, we've seen the application date needs to change to data type date. And these are the other things we're going to do. We're going to check for missing value, check for duplicates. Then we need to convert the application date to date type. Then we're going to check the data type of the various columns, like did we achieve what we set out to achieve? So I already decided on the questions I wanted to answer, and a lot of these columns, I'm not going to use them. So here we are going to just create a new data set, and that data set will only contain our columns of interest. And then lastly, we'll check the shape. So you can see the shape here. Where's the shape? It's only somewhere here. Yeah. So let's have here. Oh yeah, so we have 36 columns and this is 20,000 rows entries. So the shape is 36 to 20,000. Yeah. And even this tells us that there are no missing values, because if anyone was less than 20,000, then they're missing values. So, but yeah, we can check again. So how do we check if our data has any missing value. So we're going to use is now, yeah. So we'll call our data set. So loans underscore data dot is is now. Then we'd want to sum this, yeah. So let's run that and see what happens. So as you can see, this is a list of all the columns, and none of them have missing values 0, 0, 0, 0, 0. So we don't have any cleaning when it comes to missing values. But typically when you have missing values, you could do a number of things. You could drop them if you feel like your data set is big enough, and if you drop those missing values, because you see what happens is, even if like let me come here. What happens is, if age is missing, but everything else, every other column is populated, this whole row is going to be dropped because of this missing value. Yeah. So if you have like 20, like 20 rows with no age, those are like the whole row is gone. So your data set is reduced by 20 rows. So if the missing values are not too many, you could just drop it, as long as the sample you remain with, you feel like that sample is enough to, like, for you to just generate insights that are significant. Yes, that is the word I was looking for. So another option you could do is there's a word for it, but anyway, let me just explain to you. Impute. It's impute. Yeah, I think it's you could impute like the missing value. So what that means is, you can replace them. Let me just use replace, because I'm not sure if the word is impute. You could replace them with, let's say, the mean, the mode, and the median, and you need to have a reason why. So again, if the missing value is not too much and the mean age is maybe 40, so you could replace all missing values with 40. If it's a categorical column, same thing. You could replace it with probably the mode. So that's the most mode occurs the most, yeah. And there are more advanced data cleaning methods that you could use. So you could actually use like machine learning concepts, something like clustering, and you'd look for, because if every other column is populated, or at least a significant number of columns are populated, you could use clustering to be like, okay, this 19,995, yeah, that location, whose characteristics when it comes to whether they're employed, education level is in high school, their experience, loan amount, loan duration, like their characteristic is close to who. Because statistics, chances are high that I hung around people who kind of behave like me. So we could get characteristics of a row. And if the character, like clustering, we will put the rows that have characters close to each other together, and then it will give the missing columns. It will give the missing columns an age close to like the average, the mean age of people who have the closest characteristics to it. I hope that makes sense. And again, if these are things you don't want me to get into details with, to just explain it to you guys, educate you guys on it, do let me know down in the comments below. But yeah, in our case, no missing values, so we're not getting deep there. Then the next thing we're going to do is we're going to check if there's anything that's duplicated. And in this case, we're going to use a function called duplicated. So loans underscore data dot duplicated dot sum. Okay, so no rows have been duplicated. So we are okay there. So in terms of like quick checks, checking for duplicates, checking for missing values, because yeah, missing values can just be a pain. They can make your visuals just look ugly. And also there are some machine learning models, like if you decide to get to continue with this project and build a model that don't accept missing values. Like if you have missing values, your code will throw an error. So you have to make sure you always deal with those missing values. So what do we want to do next? We want to convert the data type of the application date from object to data type. So what are we going to do? So that's so So we're going to use a function in pandas. So pandas to date time. Here it is. And what we're interested in is the application date in loans underscore data dot, do I have it? Application date. Here it is. So now the new okay. Okay, so we can do loans underscore data dot info to just check if it worked. So as you can see, it worked. It's date time and it's no longer an object. So I already decided on like the columns that I want to work with, and I already put them somewhere. So I'm not going to rewrite that. So let me just pick it. Give me a minute. Okay. Okay, so the first thing we do is to define the columns that we want to work with. So this is just a variable. Again, a variable is just a container. So we've taken this variable and we've stored these column names in it. Then again, this is another variable called loans. And inside this variable called loans, we are calling these columns from the loans data. Yeah. And then finally, this new data set. Yeah. So we've created this new data set, and this new data set only has the columns that I want to work with. So as you can see, application date, annual income, credit score, employment status, loan amount, savings account balance, total assets, total liabilities, job tenure, home ownership status, and whether the loan was approved or not. So 0 should ideally mean the loan was not approved. 1 would mean the loan was approved. So we can check the shape of this data set. I think that checking shape thing, it never has any loans data. I always forget, and I always put like a bracket upper, but it's never there. So as you can see, we still have 20,000 rows, and then this time we only have 36 columns. Because I've called the wrong thing. Yeah, so we only have 11 columns for our new data set. And yeah, that's it for our section. We loaded our data set and we previewed it. We did some data cleaning. The main thing there was just to like only call the columns that we plan to work with. And then the one column that was not in the appropriate date type, we changed that. So where to next? So the next thing we're going to do is do some data exploration and visualization. So I usually like, so the column of work, the data set we're working with is called loans, yeah? So if you do loans dot columns, yeah, this will just list for you all the columns that are in your data set. So I like doing this so that when I'm doing my analysis, I don't have to start scrolling up looking for my columns. Like I know the columns are here. So if I want to do something with annual income, I just come and yeah, I just highlight it and I copy paste whatever I want to do with annual income. Yeah. So what's the first thing we want to do? We want to do, like, we want to just get an overview of applications over time. So year, extract the year and the month. Okay, yeah. So I decided not to do the month one because it's very messy, but I can just talk through it. So we want to extract the year and the month for the application date because we want to see how many applications do we have year over year. And then we'd want to do a count of applications by year so that we get a visualization of that. And then next, we want to do some exploration with various variables. That's the number one variable we want to look at is annual income. We can look at annual income alone. So like, yeah, we can explore annual income alone. You'll see what I mean by that. So like, for example, like the measures of central tendency, like in this whole data set, how many, like what's the mean income on the higher side, which could be like the 75th percentile, like who are the who are the high earners, average earners, and the slightly lower earners. Yeah. So okay, that all is summarized there. So yeah, so you can choose to explore like annual income by application date, employment status, loan amount, home ownership, and loan approved. Yeah. So we're going to do all these explorations. Yeah. Yeah. So what I didn't do here is not code, text. So I think 1, 2, 3, 4, 5 others. Other. Right. Okay. So we check this. Okay, so I'm very keen with this hashtags. I've forgotten the name of this language. Is it Markdown? Yeah, it's Markdown. Yeah, because it's helping me order this. So like project plan is a main title, loan approved, loan, loan approval, financial risk analysis is a main title. So loading and previewing the data set is like a subtitle here. And then cleaning the data, then data exploration and visualization. And then the data set is under loan, previewing, loading and previewing the data. What did I write here? The data. Ooh. Okay, and then as you can see under data exploration, we have applications over time, annual income, and this has 1, 2, 3, 4, 5. So meaning, because they're supposed to be on the same line, that means I put a bit more here because they're supposed to be 1, 2, 3, 4, 5. Yeah. See? So it just makes it easier for even new people if you decide to like download this and just get a view of it. Like it's easy for you to navigate what I'm doing, yeah? So other main variables that I was considering is savings account balance, credit score, total assets, total liabilities. I actually wanted to do a like total assets to liability ratio to uh, ratio. Yeah, so that's what I actually wanted to do. I didn't want to do this one alone, so we can delete it here. Then there's job tenure. Yeah, so we can decide to just get an understanding. Okay, depending on the job tenure, like are people who are like earlier on in their careers, mid-career, towards the end of their career, who's more likely to get an approved loan or not? You could look at it by application date. So are there specific months that that category, there's a spike in applications from that category. Yeah. So these are all options I've put for you guys, but I'm actually not going to do them. So the only one we're going to do is this one, annual income, and and you'll see the explorations we'll do. So you can borrow from what I do with annual income and applications over time and just pick one of these, do some exploration, and yeah, share with us, share on LinkedIn, tag me, send it to me in my DMs. I can review it, give you feedback when I get to it, and if I have time, but I'll try to at least review minimum 3 people if you guys actually do it. Yeah. Like, challenge yourself, answer more questions, like think of, because remember, if you decide to use this project as your portfolio project, yeah, and you're like during your interview process, they actually expect you to present it. It would be nice for you to come up with your own variables and justify why did you decide to explore this? What are the insights gained? So I've put this here for you, but you can decide to come back up here. Where did we do this? Yeah. You can come back to the data cleaning and you can decide to just add back any column that you feel like I left out, but there's something you want to add. Yeah. Because if you decide to use this in one of your interviews, you need to explain why you're doing some of these things. Yeah. So yeah. Let's start by we need to I feel like doing this last. Yeah, let me do this last, but okay, I'll just come back up because I wanted to move it down but yeah, let's do this for last year. So we want to understand which people, depending on your annual income, are more likely to get their loans approved. So we need to create categories, yeah? And how do we come up with these categories? We can use measures of central tendencies. And this is mean, mode, median. And on top of that, we're also going to use percentile. Yeah. So let's get the mean for this column. And we already pasted it here, so we'll just use that. So how do we get the mean of, it's called annual income? Yeah. So what we'd have to do is our data set is called loans, yeah. So from loans, we have to call annual income, yeah. So we can even let me just even show you what is happening. So if you run that, there, you've called that column. So all we have here is annual income, yeah. Then when we call this annual income, the next thing we're going to do is we're just going to use the function mean to get the mean. And then I should not have. And can you imagine that's it? So the only thing is, this is a bit messy. So we'd want to round this off. So we use the function round. And we want to round it off to 2 decimal places. So that's what we get, yeah? So we need to do this to get the mode. And once we get all this, it's going to advise on like the categories. So we'll create like 3 or 4 categories. So like the people who earn like lower, medium earners, and then high earners, yeah? So mean, mode, median, and then, I also want us to do percentiles, yeah? Percentile. So we'll do the 25th, and then we are going to do the 75th. Okay, so we do the code first, then I explain what it means actually using the numbers. So we'll just actually copy this because all we have to do is just change the function at the end. Okay, so like this one is going to be mode. This one is going to be median. And then this one is going to be quantile. Yeah, here it is. And it's 0.5, 25th. Then we can just copy this and replace it here. And then we put 75th, yeah? Yeah, and that's it. We have our mean, mode, median, percentile, and 25th percentile and 75th percentile. So I actually want this median here, because it will be easier. So now we want to print, to make this a comment, we want to print the results. Okay, so we do print, and then mean is equals to, so so this equal has to be here. So let me print that with the space, you see. So you see it's doing that. If I get rid of this, it will print it exactly as it comes out. So we want mean is equals to, then we need to put like the mean itself, yeah? So the mean is equals to mean AI. You guys, I'm just remembering how these things used to give me a headache when I was still learning. But That's why I'm taking it slowly, step by step, and not just typing, I explain. So of course, here we're going to get an error because you can't concatenate two aspects that are not of the same data type. So this one is a string and this one is an integer. So we'd have to turn this into a string. And then also remember we are concatenating, yeah? So we need to put a plus sign because that plus sign is the indicator that we're concatenating. So you see, it will say mean is equals to what is there. So we need to take this and duplicate it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. And then, so now this one is median, mode, percentile, and then percentile in. And then we can do away with this. Yeah. And then okay, let's run this. As you can see, we have hmm. Yeah, so we have our mean, median, mode. Then we have our 25th percentile and 75th percentile. So for this particular analysis, I'm going to use the mean, especially because the mean and the median are not okay. 10K is a significant difference, yeah. So I don't have that much context into the data, which is okay because you can come up with your own assumptions because you'd ideally have to explain, like, why did you decide to go with mean over median? So in this case, I've decided to go with the mean. And one of my justification is the difference between the mean and the median is not so big. And the mean is just the average, yeah? So like majority of the people, like if you take an average, it's like majority of the people earn 59. But majority of the people in terms like majority of the people actually, wait, now I'm forgetting the difference between mean and mode. Huh. I mean, mean and median. So the mean is more affected with outliers, while the median is not. So if there's someone who earns so much money, and you do a mean of everyone in that data set, like the mean could be pulled towards the higher earner, but the median is not affected by the whatever, it's not affected by outliers. So median could actually, I think we use median. Mm. Though I came into this wanting to use mean, but it's okay, we can use the median. So what we're going to do, we're going to create a column called income categories, yeah? So here, we're going to create a column called income categories. We're going to add it to our data set. And that column will just have an indication of like, this person earns below this, and then above this. Yeah, so yeah, let's jump onto that. So the first thing we're going to do is we're going to create a function. And this function is going to have if statements, and the if statements are going to just define like the earnings of these people. Yeah. So yeah, let's get into it. So we're going to, when you're creating a function, this is the keyword you start with, yeah. And the result, we are going to name it annual income. Yeah. And then the building begins. So if annual income, this is how it is. So if annual income, is less than or equals to the 25th percentile, yeah. So the 25th percentile is just like 25% of the data set, yeah. What do they earn? And as you can see here, their earning per year is about 31,000. I assume this is $31,000. And on the higher side, the 75th percentile, they earn about 75,391. So that means anyone who earns above this figure is top 25 earner, yeah. So if annual income is less than or equals to this, so those are like the low earners, then we want to return that the earnings is less than or equals to this, like is less than or equals to the 25th percentile. So this is what we do. No, it doesn't matter if you use single or double. So what we said is we want it to be less than or equals to, and we want this to be dynamic. So we put our, okay, yay. And we're going to do the same for mean and then 75th percentile. So if the income is less than or equals to the 25th percentile, we're going to print it's less than or equals to what the 25th percentile is. So the reason why I'm doing this is, like, what if the 25th percentile changes? You don't want to hard code anything, yeah? Uh, I also acknowledge that I'm not exactly following best practice here, but nah, this is okay. This is okay. But once we finish this, I'll just take a minute to review this, and then we just challenge ourselves, like, how can we make this code better? How do we make it more dry? How do we minimize a lot of copy pasting and repeating of code? Because every time you notice you're like repeating something too many times, like the same logic, rewriting it, there's a problem. There is a problem, yeah. But you see, the thing that I like about this, we can reuse it. You could literally take this and come and explore one of the other variables, and all you have to do is probably remove the AI, yeah, or decide to call all of them. That would not be nice. Anyway, let me stop talking too much. You get into action. So again, we're using if statements. If you're not familiar with if statements, I'm going to link. So at the end of this video, I'm going to link my Python tutorial, and I'm going to link like other Python projects that I've done. And yeah, you can just go and learn how functions work, learn how if statements work. So here we're just going to go quickly. So if, then else, elif. And then the last one will not be an elif, it will be else, yeah? But we leave it at that first. So here we are good. So the next thing that we want, because remember, this works exactly like a case statement or an if statement in Excel, yeah? So that means anyone who meets this criteria come when the code is running for criteria 2, like they'll automatically be excluded because they've already been included here, yeah? So let me finish writing it, and then hopefully it will make sense. So after 25th percentile, we said we're going to use the median, yeah? Uh, so here we put median, then now we want the 75th percentile. That one we just edit here, edit here. So what this thing is going to do is it will run the code and check if the income is less than or equals to the 25th percentile. The column will be the row in that column will indicate less than or equals to whatever the 25th percentile is. And then now we'll be left with people who are above the 25th percentile. So from the people who are above the 25th percentile, now it will be, are they less than or equals to the median? Then it will say, yeah, then you should name it that, less than or equals to the median. Same thing for 75th percentile. And then the last category would be, return So this one will be greater than, because now this is less than or equals to, so it would be greater than the 25th percentile. Yeah. So, and yeah, that is the end of our function. And now we want to take this function and put it in our data set. So it actually creates that column for us. So we'll say applying the function to our data set. Yeah. Yeah. So our data set is called loans. Yeah. And this new column, we are calling it income category. Yeah. And this income category is we are creating it inside the loans table. Yeah. And how we are creating it is by taking the annual income and we are applying. So this is a function called apply the result. Yep. And yeah, the next thing we do is we can call our data set dot You see, you just read it, expected this. So we forgot to put it. And there we go. So if we go to the end, as you can see, we've created a new column income category. So like if we go back to like here, when you call to the columns, there's nothing like income category we've created here. And the income category, so for this first row, the income is 39,000. So it's less than or equals to 58K. So you can come up with better namings. You just have to replace here. So whatever you want to name it, you could literally, yeah, just get rid of this, including the brackets, and then you just name whatever you want to name it. The reason why I'm putting these brackets here is because it's helping us output whatever the content of like the variable you're calling. Okay, so now that we have our categories, we'd want to know count of all applicants by that category. We'd also want to know count of approved applicants by that category. And the whole point is to find out, okay, is it applicants who earn averagely, highly, lower, who are the majority of the applicants, first of all? And from from like all applicants, who are the majority of applicants? Is it people who are high earners, low earners, or uh, middle earners? And then from the clients who get approved, who are the majority of the clients who get approved? Is it a certain income group? So I hope I've made sense. The first question we want to answer is, which income category makes the most applications? And from all the applications we received, which income category is the one that is frequently approved? So they have the highest number of approvals. So very high level. And yeah, I'll challenge you to get a bit deeper. Yeah. So first thing we want to do is we just want to get a view of, okay, this our nini, the one that we generated, what does it look like? Yeah. So we want to call income. Why is it not coming? Let's paste it. So I think by now we all know what this will do. There's no need for dot. You put the dot if you're when you put the dot, you don't need to, like, it's either dot income categories or you do what I've done. Yeah. So, but because this one has a space, we'd have to do this. Yeah, because it has a space. If it didn't have a space, let me look for one that I already did. Anyway, you'll see what I mean. Like there are two ways you can call a column. So you can do loans into square brackets income category. You can do loans dot loan approved. Okay, yeah. So you see now, because this one has a space, I have to call it like this. This one doesn't have a space, I can call it like that. So just explaining that. Okay. Then we want to know like the unique values here. So you're just going to use a function called dot unique. So this dot unique is like select distinct in SQL, and yeah, in Excel or Google Sheet is the same thing, unique. So as you can see, these are our unique categories: below 48,000, below 74,000, greater than 74,000, and below 31,000. So 31,000 is the 25th percentile. And then 48,566 is the median. So that's the category we have. So how do we get like, we want to get a count of the number of applicants for each of these categories. So we're going to use pandas here. Yeah. And we're going to do, so of course we get the loans table. Yeah. And we want to group by. So this group by is very similar to the group by that we use in, what is it called? What is it called? What is it called? SQL. So we want to group by income category. We're grouping by income category. Yeah. Then we want to get the size. Yeah. Size is a function. Yeah. And then we're going to sort the values. And we want to sort these values in, you can do it in ascending or in descending order. So if we do, why is it not auto-completing for me? Ascending, if ascending is equals to true, then it will sort it in ascending order. And we want to preview this, so it would be dot head. But we'll get rid of the dot head and then you see what happens. So as you can see in, yeah, where are they? Hmm. Okay, so this is too perfect. Like 5,000. Okay, not let me not say this is too perfect. So at this point, okay, it's still worth it because that means they're equally distributed, yeah. But for the purposes of this analysis and just trying to demonstrate, like doing visualizations, let me turn this into mean. Because you see what's going to happen is if let's say we visualize using a bar, it's going to be equal, yeah. So we can run that this has shifted. And yeah, the distribution is at least, there is a distribution. It's not like evenly distributed. So now you can see people who earn above the 75th percentile like 5,000, people who earn below the 25th percentile and below are also 5,000. People who earn between the 25th percentile and like the mean, so tuko katikati, people who are in the middle, there's a total of 7,522 of them. And then did I cover everything? Then people who earn between the mean and the 75th percentile are 2,478. So I told you guys I'm going to remove this, so I show you what happens when you run that. Oh yeah, it still showcases all. So if you do head and you do one, it's going to show you the highest. So this is another way to ascending, it's going to show you the lowest. So if you make this false, so that means it's from, this is descending from the highest to the lowest, you'd get the highest. So this is one way to answer the question of like which income category has the highest number of applicants. But yeah, so this one we want everyone, although it's usually head does top. I think the default is top 10. You can check that out. You can Google. So yeah, this is what we get. So when we look at this like this, like it's a bit painful. Though, okay, not so painful. Like it's not very appealing. Yeah. So would ideally want to visualize this. Yeah. So this visualization again, I'm not going to type the code. I already have it somewhere. So I'm just going to paste it. I'm just going to paste it. I'm just going to paste it. I should probably show you where I am pasting it from. Okay. But I'm going to explain what it's doing. So we're deciding the size of our visualization here. Yeah. Then we're deciding the color of our visualization. So we pick the palette 0. Then in the x-axis, we want to get the values of the application by category. So what we're going to do is this whole output here is what we are going to call application by category. And we have to run it, but let me not run it because so we have to run it, or else now if we run this, we're going to get an error because it will not recognize it. Then the y-axis is the index. So that's the categories, yeah? This is the values, this is the index, yeah? And then the color is the base color, which is the palette we defined. Then, yeah, we need to label our x-axis, our y-axis, and then we need to have our title, and then we need to show our plot. So if we run that, as I said, we're going to get an error. Why? We had not defined application by categories. So we need to come back and run this again. Now it's been defined. Okay. So now when we come and run this, we'll get our plot. So here we put it in a variable. So when you put it in a variable, you have to run it if you want to the output. But here we go. So now you can quickly see. You see here, you'd have to like think through, read, but this one, without thinking through, reading, immediately you can see which category has the highest number of applicants. So clearly it's the mid, like I'd say lower mid, because mid for me would be these guys and these guys. So this is the upper middle and this is the lower middle level earners. So the lower mid are the ones who make the highest number of applications. Yeah. Yeah, they're the ones who make the highest number of applications. So I want us to repeat what we've done here. Yeah. But in this case, we want to do it only for people whose loan was approved. Yeah. So how would we do that? Yeah. So the first thing we have to do is we have to call. So we want loans approved. Yeah. And what is this loans approved equals to? So our table loans. Yeah. And then the column we're interested in is loans approved. Yeah. But we want where loans approved is equals to 1. So me and my curly brackets. So we get rid of this. So we want where loan approved is equals to 1. Can someone in the comments down below let me know I'm using double equals and not single equals, yeah? And then now we're just going to come back here and take what we had. And then this time, instead of calling income, instead of grouping from loans, we are going to, so actually, let me run this first. I show you people. I've gotten so used to, so let's run that. So let's figure out why we have that error. But wait, if I do this, and then, but we're going to come back and figure out that error. And we have loans approved. So instead of loans, we get it from loans approved. Yeah, we need to figure out why we have that error. So, of course, my first instinct is to throw it into ChatGPT. But first of all, your first instinct should not even be to throw it into ChatGPT. You should read this error and try and understand what the error is. Yeah. But when I went through it, I realized the location of the bracket was wrong. So this bracket, it was opening from here, but it's supposed to open from here. Yeah. So if we comment this out and then we run. Yeah. So ideally, this is so it's taking the loans approved uh column. So this is taking the loans approved column, yeah, and then it's only selecting where it is equals to 1. Yeah, so that's what it's basically doing. So if we comment that and then we run this, and then now we run this. What is happening to me today? List object has no attribute. Group by. So let me just run through that and just figure out why I am getting an error. So loans approved dot group by income category. Hmm. Hmm. Okay. Hmm. Okay. Okay, let's try and rerun all this, like the libraries, because group by is from pandas, and see if that was the issue. Because why is it not recognizing group by? Does that mean, okay, so that is not it. So I called on the help of none other than Madam Mr. ChatGPT. So basically, how I did it here, it was like it resulted into a list and not a data frame. But now when you do it like this, it's calling a data frame. And yeah, what was the error again? I need to read the error. Okay, I lost my error. But just on the initial one was a list, and now this is a data frame. And yeah, so the error you're encountering occurs because you're attempting to perform operations on a list instead of a data frame. So in your code, loans approved is defined as a list, which is why it raises the attribute error. Oh, yeah. Anyway, so on that note, so what I'm planning a pandas series, and I'm also planning to, so I've done like the tutorial that I'm going to attach at the end of this video has like data types, like introduction to data types for data science and data analysis, but they're very basic data types. So I plan to do a part 2 of that video, which is going to cover like advanced data types. So that includes like what's a list, what's a data frame, what's a dictionary, what else can I remember? Now queues, but that now goes into data structures, or which, yeah, data types, data structures, yeah. So if that's something that you're interested in, again, stay tuned, join the family so that you can be able to intuitively like figure out what's up with some of these errors. But yeah, so there we have. So we have filtered for where the loans approved are for where the loans are approved, and now we have account. So what we can see here is an insight that does not shock me. So majority of the list category, the category with the least number of approvals are the lower earners. So it would be nice to just write down our insights. So like here, we could quickly write majority of the applications are by lower, medium, lower, medium lower. Is that what I called it? Medium lower earners. Medium lower. Does that even make sense? Hmm. I'm just thinking of a better way to phrase that. Anyway, you could improve it. Let me not obsess over it. And then here we are seeing the category with the list applicants. So the list approved applications are the lower. Yeah. So this is just I got some feedback from you guys that you want me to also focus on the insights. So this is just like a couple of insights. So one thing you would tell someone very high level is, yeah, if you want the chances of your application to be higher, work towards increasing your income, whether it's your employment income, you have other side hustles, put it all there, demonstrate that your yearly earnings are higher. So that will actually increase the chance of your application getting approved. Yeah. So the bank, the financial institution in question sees you as less risky. I'm also giving a disclaimer that this is a very high level insight. Like I'd want to understand this by age, by employment category. So is it the same for someone who has a business versus someone who is employed? Because in my opinion, someone who has a business who earns less than someone who's employed, I would think that that person who has a business, even if they earn like 10, 20% less than someone who's employed, is less risky because the business is yours, especially if this is an established business that has been around for a while. The chances of that business going anywhere is low, but with unemployment, anything could happen. The company could collapse, you could get laid off, you could fall sick. As a business owner, even if you fall sick, as long as your structures are in check, your employees could keep running your company for you for as long as possible. Yeah. So like going forward, I'm going to really take time, sit and do like a proper project, like everything we've done, plus the insights, and actually summarize the insights for you at the end. But for this particular project, I'm not. I'm just going to demonstrate for you like how you'd ideally do this project. Because what I'm trying to challenge you, what I'm trying to challenge you guys to do is to just close the loop. So this is a very vague insight. Yeah, it is an insight. It's something that we've found. So for sure, we know like people who earn above the 75th percentile, they're the least there. Yeah, they're the least applicants, but majority, like clearly most of them, like having this as a percentage would also be nice. So this approved divide by the total number of, what is it called? Just the total number of applicants, yeah? So total number of applicants or total number of that category. So this is what percent of that. So for sure we'll see it's a high percentage of, uh, who are they? So that's 3,000. Yeah, 3,200 as a percentage of 2020. This is greater than, so it's, oh, this is also, oh yeah, 5,000. So clearly that's more than 25%, and all the rest for sure, that is less than 25%. So to do so, nice to have this as a percentage, because when you give someone insight in terms of count, like it's really hard for, if I'm the one in the interview panel, or in this case, it's actually an interview panel, like you're just trying to share your report to stakeholders, whether it's written and or slides, and you're actually going to present it. Like giving figures like this is not very intuitive. Like you'd rather tell me it's 25%, 50%, etc., etc. Just just advice over there. So approved applications by category. So what are we going to do next? We want to visualize this. So we're just going to copy this, paste it here. And then now we'd want to take approved. So everywhere there's applications by category, we do approved by category. Number of approved applicants, income category, number of approved. And there you go. So as you can see, so people who earn below the 25th percentile have the least number of approvals. People who earn above the 75th percentile have the highest number of approvals. And then people who earn below 59, below the mean, but above the 25th percentile, have the application approval rate is almost the same as people who earn below the 75th percentile, but above the mean. Again, having this in percentages is more valuable than having absolute counts. Absolute counts are not very intuitive. Like I would not know if this is a good and a bad thing, because what if this count is just high, but as a percentage of that category, it's like maybe 2% of that category that are being approved, while the count could be low, but it could be like 25% of that category being approved. So yeah, just a caution there. And that's something that we're going to implement in projects going forward. So I'm not just going to be giving you advice on best practice. I'm also going to try and implement some of these things. But remember, my aim is to not just feed you and give you code that is ready. I'm also just challenging you to go and practice, do these things on your own, come up with new questions, and yeah, show me. And then at this point, I can actually just let you guys know that I'm actually going to do this same project, but I'm going to do it on SQL. And the plan is to visualize it on Power BI or Tableau, or we could visualize it on both. So if that's something you're interested in, stay tuned. That project, it will come towards the end of this month or early next month. Yeah. Okay, so yeah, and there's our visual. So you could literally just take this code, like for example, this. Actually, we'll start here. So instead of annual income, you'd have to replace it with savings account balance. So everywhere you see annual income, you just replace it with savings account balance, and then you put like the appropriate variable name, and you can literally replicate this analysis for all these variables. And that's why I was like, I'm not going to do them because it's literally just the same thing. But you see that thing of like copy pasting, replicating is not really the best way to do it. So something that I'm challenging myself and I'm also challenging you is how can we put all this work that we've done in a function in a way that we minimize the duplication? Like, how would that happen? So if that's something that you'd actually want me to build, you'd want me to see, you let me know down in the comments below. I'll do it and I'll share that analysis with you people. And then the next thing that I'm going to challenge you guys to do is, as you saw up here, I give you other things. There's application date, employee status, loan amount, home ownership status, loan approved status. So you could be like, okay, so we've seen that majority of the applicants are like who are between the people who are between the mean and the 25th percentile. Yeah. And it's people who are above this earning category are the ones who have like the highest application rate. But if we introduce another variable, so we want to see this by maybe if you're a homeowner or not, if you are employed or you're a business owner, like would we still get the same insight? Even if someone's earning is low and they're a business owner, or their earnings is low and they're a homeowner, are they likely to get are they likely to like is their approval rate likely to be the same as someone who has a high income and does not have all those things? So yeah, like if someone tells you to do an analysis to just guide them and give like I come to you and I'm like, hey, please let me know what do I need to do for me to have a very high chance of getting my loan approved. Mix all those variables, come up with your insight, and yeah, give 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 your client, your stakeholder, whoever is interested in this data, the insights they need so they can do whatever they need to do in order to increase the chances of their application being approved. Yeah. And just take that mindset, that way of thinking, that I don't know if I should call it like project plan process in any application you're doing, like what's your end goal? When you give these insights to your stakeholder, how is it going to help them achieve their various goals, their mission, their objective, etc. So yeah, that's my challenge to you. And yeah, so I have this here. So I thought of this like after I had done this, yeah, like I'd come up with these steps. I was like, okay, it would also be nice to just show you guys like, okay, what's actually like, what would this look like? What would the code for this look like? Like, what is the actual count of applications by year? Again, so I prepped for this, of course, before I started it, and I'm just going to like share with you guys the code there. I'm not going to redo this whole thing. I'm not going to, Nini, I'm not going to type it. So here what we're doing is from loans, yeah. So from the table loans, we're creating year, yeah. And that will be loans, application date, I'm a bit tired. So dt.year is the function that we're using. Then dt to period M would stand for month, yeah? So I would want to print that out for you people. For you people. So you see, anyway, yeah, I need to call this a project. Yep, I need to call this a project. But yeah, let's just run that. You'll see what happens. Yeah. Yeah, I'll put up a tutorial, do another project, but put up a tutorial first. Not planned, something that I've decided to come up with now. Because I'm like the things I've mentioned, like the Pandas series, uh, doing this project again, but this time in SQL and then visualizing in Power BI or Tableau or both. That's something that I'd really planned to do. But I'm like, yeah, I'm a bit exhausted. So this part of the project is not doing you guys justice. And yeah, yeah, so I will do a tutorial, a project that's going to be heavily around what's the thing, dit functions in Python. Yeah. Yeah, and maybe this is a lesson to me. I just need some time so I get like my equipment so I don't have to sit down for like an hour plus, sometimes 2 hours. I do these things in one sitting. Yeah, it can be a bit exhausting, but when I get my equipment, I can do it in portions. So I can decide, let me do the data cleaning first, take a break, then I come to data visualization, take another break, and then I just merge the projects, like the pieces. Because yeah, whenever I get towards the end of some of these projects, especially the really long ones, I get a bit exhausted. And when I'm exhausted, I'm not giving you guys the best. But yeah, we are working on getting like a more powerful laptop, getting editing software so we can shoot in pieces and I can always be at 100 even when we get to the end of these projects. But yeah, so here what we are doing is so application per year. So this is just loans grouped by year, and we created the year, and we are extracting the year from the application date, which you guys are familiar with by now. So size will just tell us the size, like the count of the people in each of those years. Then this you're familiar with, size of our plot. and then application per year, the index, the values, and then yeah, and that's it. I would want to exclude this last data point because I don't like how it looks. Like it's yeah, I just don't like how it looks. Yeah. So I guess this is where like some data cleaning practices comes in, feature engineering. If I exclude that, it looks like it's still going to be a zigzag, which is messy, which might be a sign that yeah, maybe it's not worth it, maybe something worth looking at is for each year, number of applications per month, etc. Otherwise, guys, that's it from me. If you've stayed to the till to the end, thank you and good for you. I really hope you've learned something. And if there's anything, like if you have a particular data set that you'd want me to do a project on, please do let me know down in the comments below. If there's any concept you'd want me to just show you guys, be it an SQL concept, Python concept, Tableau, Power BI, Excel, Google Sheets, I'm your girl. Just let me know what you'd like to see. And yeah, I have a bunch of SQL tutorials. We cover what are they called? Basic SQL, intermediate SQL, advanced concepts. We also have like basic Python. Okay, I wouldn't call it basic Python, but yeah, introduction to Python for data analysis and data science is a tutorial that I already have up. I'm going to link it at the end of this video. So we're going to link the Python tutorial and we're going to link like other Python projects that I've done. And yeah, so that's just basically a summary of some of the things that I do in this channel. I also do sit down videos, but yeah, I took a break a bit because I lost my phone. So just planning to get another phone, and then I get back to doing sit down videos and just giving you advice and just telling you like, how did I get here? How should you write your CV? How do you carry yourself during an interview? What skills do I think you need to learn right now for you to get into the data science space? And of course, for people who've been here for a while, especially ever since I came back, because I'd taken like a break, like a 6 months break. But ever since I came back, like that break, that a lot happened during that break, including the fact that I've been learning DBT. I'm using DBT professionally. I've learned how to use Sigma. I've used Sigma for like paid projects, same to DBT. So that was a not necessarily a break, but it was a nice break from YouTube. Learned so much, and I'm really excited about just getting everything in order and just sharing my skills now that I'm getting more into the data engineering side of things, data science side of things, just trying to do more data science and data engineering projects for you guys over here. And as I'd mentioned, if you'd want to see this project continued, so we turn it into a data science project, we build various models, we tune these models, like yeah, hyperparameter tuning. Like, yeah, if that's something you want to see, do let me know down in the comments below. Otherwise, guys, that's it from me. Thank you for staying till the end. See you in the next one, which is a bunch of SQL tutorials before you see anything to do with Python. Bye.